In the last video, I showed you how to create a wall with a door in it that would open when your FPS controller walks up to it. In this video, I'm going to show you how to complete the level by adding the dynamics and mechanics that are needed to create some challenge in the game. And that's going to be done through C# coding, as well as adding different elements and objects into the scene. So to start, let's go ahead and demo the level. When I come into the level, I can look around and see that I have a sky dome, as well as a terrain and landscape. I've got some things with particles, and there's an object over here with particles coming out of it that is actually a portal that will take me to the top of the roof. There's another portal up here and these little floaty things. This portal will take me to this mountaintop so I can see my entire terrain as well as my sky dome. And we'll just go back down to where we started. Now, to begin, I'm going to walk around here. Notice that my footstep sounds change to a water sound when I'm in the puddle. And I'm going to walk over here and pick up one of these power-ups. And you can see that the color of the light changes on the door, and I get some text that tells me that I need to go pick up some more of these symbols. Now I can see one's over here. Now that explosion was a booby trap that I avoided by continuing to walk. And here's the pickup that I want to get. And as I pick them up, you can see that the GUI image on my screen changes. It got a little bigger, so that means I'm getting more power. I'll go ahead and go down to this platform, and it's a mini game where we throw hatchets at these creepy looking clown targets that are floating in the shark infested waters. So we want to try to hit those. So we hit all three of them, and what we can do then is pick up this last power-up. And I'm just going to go to the top of the mountain here to teleport back across. And I need one more of the power-ups. It's on the top. So we'll go ahead and go up there. There it is. We'll go grab it. It says the light turned green. So let's go over and try to open the door. The door opens, and inside we have this torch. And I want to take the torch outside. And I'm kind of stuck up on those trees there. Let me just try to walk around them. We're walking through the sand, and we get over here to where there's some logs, and I'm going to throw the torch, and actually I missed the logs. Let me go pick the torch back up. There we go. And so we'll go ahead and try throwing it again. And that runs the end sequence. And then it starts over again. So I did want to show you the death sequence over here. If I do get hit by this booby trap, there's a platform with some bricks there. If I walk under it and the bricks fall on my head, then I die. a camera is spawned and a dead image, and it restarts again. I can also walk down here, and if I fall into the shark-infested waters, I also will die. So those are the different challenges in this level to get through the door and pick up the torch and then light the signal fire so you get rescued. It's a simple level, but it's got all the parts in it that we would want. It's got a mini game, it's got some challenges, and it's got a win state as well as a death and restart state as well. So let's start by looking at how these different parts of the game are created. So the main parts in this game are the door challenge, which is to pick up the power-up objects to open the door. The axe mini game gives you an extra challenge to get one of those power-ups because it's too high to pick up, and the only way it's going to animate down to your level is by throwing the axes and hitting all three targets to explode the bulb on the nose of the clown and then get the last power-up. If you fall in the water, you will get eaten by sharks and you'll die. And if you walk under the booby trap and stop, then bricks will fall on your head. And you'll also die that way and restart the game. To win the game, you open the door and pick up the torch, and then you have to walk over and light the signal fire. That involves some particles, picking up the torch, throwing the torch, and hitting the signal fire. That triggers an end sequence, a win sequence that will spawn a camera, instantiate a camera, and fly it up to where the plane is and show you the view of the plane seeing the lit signal fire. And then the other scripts that I have to make it a little more interesting is some portal scripts to make you move around the environment a little faster, and some environmental triggers for making different sounds when you walk on the sand or you walk on puddles. So those scripts involve collisions and triggers. That's something that you want to learn. It's a fundamental core mechanic in most games, is to collide, have the player collide with different objects, or have objects collide with the player and trigger something. It could be the death state, or it could be the win state, or opening a door. So all of those things are done through some kind of collision and triggers. So we're using certain built-in procedures inside of Unity called onCollisionEnter and onTriggerEnter. We're also using getComponent to get various components on media objects, as well as transform components on other game objects to either move them or to play some sound or to play an animation. There are some timers that I'm using in order to bring up some text for a little bit of time and then have it disappear, or in order to automatically close a door after you open it. So those are being run by timers that are using Unity's game loop through time.delta time. I'm also using visual feedback and some prompts through text hints that show a text object that will give you some kind of message to the player, and you actually use a send message dot syntax to show that text. And then there's also some other visual feedback on the GUI through textures. And I'm also using an instantiate command to create things when they're triggered. In some cases, it's going to be like the throwing of the torches or the throwing of the axes is basically a shooter mechanic that is being done through an instantiate command. And it's instantiating a prefab, which a prefab is a master object that we spawn in the scene to have it be propelled through some kind of physics as a rigid body. And in some cases, it's also like the camera in the wind sequence, so that it spawns a prefab of a camera with some animation on it that will actually take over your camera, your game view, and you'll see it go fly up in the air to where the airplane is. So all of that's done through instantiate commands. And there's fundamental coding concepts that we're using to make all this happen, to create all these scripts. You have to understand the basic C# syntax, what a class is, what the start and update built-in procedures are, what terminators are, what the line numbers mean, and how errors that come up point to line numbers, so you can go find your errors more easily and debug them. Variables, both public and private. Public, so that we can actually plug them in. Types of variables, declaring a variable versus assigning something to a variable, referencing global variables in multiple scripts, and using arrays for things that are going to be inside of a variable that you have a lot of things that you need to pull out. And we do that with some textures. Built-in procedures and commands, I've talked about some of them already. Custom procedures and coroutines. What's the difference between a procedure and a coroutine? Coroutine has a delay built into it, a pause, and that's useful for certain things to allow music to play or animation to run. Some general syntax for writing procedures and putting arguments into procedures. Conditional logic, if else statements. How to evaluate those, how to put not in an evaluation to change the syntax, and nesting of conditional statements. How to play media, playing, stopping, and pausing audio and animation is critical to doing a lot of the things that was in that demo. And then controlling textures on 3D objects and in the GUI, so you're making them visible or changing them. And enabling visibility on objects using dot syntax by enabling equals true, and then putting in player input through mouse and keyboard references. So to begin looking at the parts of this game level, let's first look at the main challenge. So that is to open the door with the power-ups. And there are several scripts that we want to look at for that and just review that. We've already looked at these in class because they're based on the scripts by Will Goldstone in his book 3X Game Development Essentials. And we've worked with those scripts a little bit. These are adapted from those scripts, but we've updated and changed them for a slightly different game level. So I've made changes to all of the scripts and updated them. So we want to take a look at those. And the inventory start script that we were initially using should have been changed, added to become the inventory script. And at this point, I'm using inventory torch, which has all the latest torch stuff as well as the win sequence that I'm using now and the new mini game. So we'll go over that script. The main thing about that script is keeping score of the charges as you're picking them up. And we're also going to go over the trigger zone hinge script, which is an update of the trigger zone script. And that is on the main structure that you want to get into that has the door that is locked. So we initially had a door that just opened and closed. Now it's going to be locked, and we need to pick up charges in order to open it. And so there's a script to manage that, and that's the trigger zone hinge script. And then the power up pickup script is going to be the script we use to pick up the power objects and get a charge each time we pick them up. And then the door manager script is now a door animator script that is on the hinge of my door, and I showed that last time in the previous video. So we want to look at these scripts inside of Unity. And inside of Unity, I've organized these scripts into different folders so that each folder here contains one of the main parts of this level. And it's in an updated scripts folder that I've uploaded to Canvas for you to look at and go through these scripts. So the first one that I want to look at are the door challenge scripts, and there's 1, 2, 3, 4, 5 scripts here that we want to look at. And we want to look at each one thinking about the fundamentals of coding that I'm trying to get you to learn. I've also organized my hierarchy a little more at this point. If you notice, I have very few objects in my hierarchy, game objects in my hierarchy, but they all have arrows next to them because they're really just the top level of the main part of that game. So, for instance, I have one for the entire mini game, and everything in the mini game is underneath that one empty. And when you create an empty, if I create one here, it's not created in the center of your world. And if you're going to organize your game as you get more and more stuff and you don't want to have to wade through it, it's good to organize it by creating empties like this. But if they have numbers in their channels, if they're not centered in the world, then when you parent other things under them, they may change the axes, the values in the channels of the children, because the parent becomes the world axis of the children. So if I'm doing animation on different objects, that animation is based on the world center. And if I give it a new parent, then it's going to change its world center. And so it's best to go in and go into your cog icon and reset the position of the empty that you're going to parent something under. Don't do it after you parent it because that could mess it up. But definitely do it before you parent it so that this is just becoming the world center for whatever you're going to parent under it. And that's what I've done here for a lot of these different things. And so the two things in this game that we're going to work with to to begin with here is the Outpost New, which has all of my models for this outpost object, what used to be the outpost. It's the main structure that has the door, and the hinge that has the animation for animating the door that I brought in from Maya. The door is also under there. It's on its own level, child to the hinge. And then there are all the other pieces in this outpost that I brought over together from Maya. So I made the rest of the outpost inside of Maya, created all the different parts of it after I finished the front wall and the door. I just used the same texture maps and the same windows to create the sides and the back and make all of those transparent in the same way that I did with the front. And I also added a top that again is just a cube that I've subdivided and pulled some points on it to move it up and create sort of a thatched roof type of look. And so all of these objects are pretty simple. The sides and the back are really just rectangles that I've texture mapped. And inside I made a ground as well as a rock that has a torch stuck in it. And the torch stuck in the rock is different than, I have a duplicate here, which is the torch that is going to be spawned when you pick up the torch in the rock. That's part of the wind sequence. I'll talk more about that later. But the actual model here was brought in together as one piece after you created all the different top and floor and roof and everything. I took that and put it all underneath one group node. So I just selected it all and did a Control G to group it all underneath one group node. And I exported it or send to Unity selection. And I didn't bring actually the front wall and the door with that because I already had I didn't bring the door with that. I brought the front wall, but I didn't bring the door because I already had the door made and had a script on it to open and everything. So I just brought in this other stuff and fit it around the door. So that exported as a standard FBX file. Didn't do anything special with that. And when you're inside of Unity, of course, you're going to go and select the models when they come in. Here's the outpost that I brought in. And the most important thing is you're going to set the scale factor to whatever you set the scale factor for the door. If you brought the door in initially, I set that to 100. So I set the same scale factor so it would fit the size of the door. And then I went to materials because I skipped rig and animation because there is no animation on this object. The door is the only thing that's animated. So everything else on this structure didn't need to have anything set for that. So it's just set to none. And then the materials I set to use external materials and local materials folder because I want to make sure that I can go in and adjust those materials if I need to. and then I just dragged it into the scene. Make sure all your texture maps that go with it are in your textures folder with all your normal maps and everything. You might have to plug in the normal maps, which is why you want to be able to edit the textures on this. So if you select, say, one of the pieces that you bring in, let's say this side wall right here, if I select that piece, once I pull it in, I might open it up and see that the normal map is not actually in there, and I'd have to drag it in. You also have to make sure that your normal maps are set to normal map inside the texture type. I often also set my ISO level up a little bit to maybe 6 or 8 or something, and I check the max size of my maps to make sure that it's set in relation to the size that I created it inside of Photoshop and Maya. So if I'm using a 1024 map, I'd use 1024, and if I'm using 2048, I use 2048. Sometimes you get bigger if you're doing a background or if you're doing a sky dome. My sky dome is actually at 8192, so it's a pretty big file, but that's because it surrounds everything. Incidentally, remember that the sky domes are created up here in your window. Rendering lighting settings is where you set your sky dome material, and you have to create a material for it in order to be able to plug that into here. And that's just creating a material in your materials folder by going to create material, and then when you do that, give it a name and set it to a Skybox cube map shader. That's what you want to set inside of here. You have a whole area of Skybox, and I'm using cube maps. Now, the reason I'm using cube maps is because I am using a 360 rectangular texture map for that. And those are special maps that are done with either a 360 camera or by stitching together a bunch of images that you take in a circle all the way around. And that's what I'm using for my sky dome. It's not a sky box, it's a sky dome, and it's using that setting. So you plug your texture map into the material once you create a Skybox cube map material, and my texture maps for that have to also be set to something that will be a cube map. So you can see these round ones, a cube map ends up looking round in your viewer. If I click on the one that I'm currently using, you can see that I'm using a texture type default, but my texture shape is cube. And so you're going to want to switch from 2D to cube and make sure your mapping is latitude longitude layout, not the 6 frame layout, because I'm not using 6 separate images. I'm using one big 360 panorama shot. And those shots are going to look like the one I'm actually using here. I got from Adobe. So if we go take a look at what this panoramic map looks like inside of Photoshop, we'll see that it's a very large map. If I look at the size here, this is 10,000 pixels wide by 5,000 height, and it's 300 resolution. So you're going to want to scale that down. It doesn't need to, it can be 72 resolution, and you want it to be one of the sizes that are standard for a background inside of Unity. So here you can see that I've taken that image and I've scaled it into another image that is 8,192 pixels wide by 4096 tall at 72 resolution. And I've taken the sky here and I've scaled it so that it fits within the top half of the image. So everything that's in this scene is going to be covering up the bottom part of this image. The terrain, the ground plane, is going to be about where the middle of this image is. So I've scaled it so it's slightly below that, below the horizon line, so that if you're up on a mountain, you won't see the edge of it. And this will wrap on the inside of a gigantic sphere that is inside of Unity as a sky dome. And because it's equirectangular, you won't see the kind of distortions that are there. Equirectangular images look distorted at the top because they're going around a gigantic sphere. And if you, say if I go to the Adobe stock image, you can search for equirectangular images for skies and find a bunch of different ones. Some of them will have ground, but you know that they're equirectangular if they look circular, if there's a circular distortion happening on the clouds at the top of the image. And a good one will have enough sky because you want to make sure that at least half of the image is sky, and because the rest of the image is going to be underneath your terrain, and some images will be just sky, but you want to try to find stuff that is going to have that noticeable equirectangular distortion. And that means that when you map it on your sphere inside of your game engine, that it actually will look correct. So if I hit play here, inside of the game engine, and look up, everything looks correct. It doesn't look distorted. It comes to the center of that sphere at the top, which is called the pole, and you don't see any distortion, and everything looks normal and going out to the horizon line. That's what you want with a sky dome. And so you have to make your maps according to that. And when you make it 8,192 pixels, that's the size. You'll see the sizes in here that you want to create your texture maps for. So I made a 8,192 pixels wide by 4096 tall. That's going to be the perfect size for a sky dome. And you set it to the max size here. So, you apply that on there and it'll work perfectly for you. There are some things to set up here when you set that. After setting the cube shape, you also want to fix up your edge seams, and that's mainly it. Setting your mapping, your shape, your mapping to latitude, longitude, and fix up your edge seams. You might also want to clamp the wrapping. The wrap mode set to clamp because it shouldn't repeat. It should fill up the entire texture map. Okay, so that's just part of setting the lighting and everything, because the sky dome here actually is projecting the atmospheric lighting. The ambient lighting in the scene is coming from the sky dome. And that's set up there in the lighting settings. If you look at it, it says that that your skybox material is what's going to be the source of your environment lighting. And you can see it right here. It says skybox is the source of the environment lighting. And you can see the effect of the sky dome on the landscape by plugging in different sky domes and just looking at how it changes the lighting. So for instance, if I go back to my sky dome material and plug in a different one than I currently have. I have a few different sky domes that I've created. And so if I plug in this one that is just a normal day, you can see that it changes the lighting on my scene completely. Now I still have some lights in here. I've got a couple of directional lights that have some color tinting on them. So the ground still has some a little bit of a purplish look. But you can see that the mountains and everything, they're much lighter because this skybox is much lighter. And if I go in and plug in this one, which is got a lot of purples in it, then you'll see that the ground plane is actually even more purple now than it was with the map that I just had in there. And then the one that I'm currently using has a lot of oranges in it in addition to some blues, and so it will produce some oranges in the landscape, bring out some of the oranges. So the sky dome is really important for the aesthetics of your scene, and once you have it in there, it's going to really affect your lighting too. So let's go back to our outpost. We have the outpost here, and we want to look at how we can, how the scripts are keeping us from entering the outpost unless we have 4 power-up objects. Now, power-up objects are also in this scene under an empty, and if we select them, we'll see that they've got a collider on them, they've got an audio source, and then they're going to have a power-up pickup script. So that's one of the scripts that we want to look at first. It's a fairly simple script. We'll go to our door challenge and open up the power-up pickup script. Okay, so we've got that script in here now. And I'm just going to close some of these other ones that we're not using right now. And so this script is a fairly simple script, and let's take a look at some of the fundamental properties of coding that I want you to know. Now, when you create a script, there are certain built-in things that are going to show up in that script, and it's part of the initial template that Unity gives you, and it has the syntax and everything built into it. And that's going to be these 3 lines at the top, which are using system collections generic, and using Unity Engine. These are the things that you need to do all the basic stuff that you want to do inside of your Unity script. Now we will add some things to that. There's a UI line that we're going to add, and some other things when you need to load in scenes. But these are the three that you're always going to see in there. You're also always going to see line numbers on the left here whenever you come into Visual Studio to work on your script. And those line numbers are important to know because when you get error messages inside of Unity, you're going to use those line numbers to help you find the errors. When it creates a script, it's going to create a class for that script, and it's going to be named the same as the script name. So PowerUp Pickup .cs is the C# script name, and then PowerUp Pickup is my class name using MonoBehavior, which is Unity's C# language, or their editor syntax. So in this case, once you have a class, you're going to have an opening of that class and you're going to have a closing of that class at the end. And sometimes I would put in some of the scripts, you might see that I've annotated and put in something like open class or start class. And at the end, I might put end class next to the very final one. And you got to make sure you put your 2 forward slashes so you have your line comment. And that will just keep you from getting confused of what these curly brackets are for. If you are adding stuff in here and you forgot to add a curly bracket, you won't get confused that this one goes for something else because you have a comment next to it that says it's for the class. And when you click next to that end curly bracket, it should highlight the corresponding opening curly bracket at the top. And in this case, it's the very first line, which is for the class. After that, I always put some kind of comment to tell me what the script is about. And sometimes if it's multiple lines, I'll put a /*, and then on the second line, I'll put a */ and it will comment out anything between those two lines. So if I want to write more than one line, I can. You can just put a second line here. So if you don't need that, then you can just use a single line comment, as I've done here for the variables. So the first main thing that I put in my script after the comments are all of my variables. I put them all at the top so they're easy to find and easy to see what they are. And if they're at the top, that means you're going to be using them somewhere down further in the script. And you can see there's not much for this script. There's only one, a public float rotation speed. And it's being set to 100, and it's a float. So whenever the syntax of C# is that if you're using a float variable, which is a decimal number, then you have to put an F after the decimal number. And then you always have to terminate your line with a semicolon. The only time you don't use a terminator is when you're creating a procedure or working with a procedure. A procedure doesn't have any semicolons. It has them in the lines that are inside of the procedure, but not the procedure itself. So the syntax for procedures is different than for lines of code, and you can't leave off the semicolon on a normal line of code. If I were to accidentally not have that there, you'd see red come up inside of Visual Studio. That's telling you that there's some problem here. And if I actually saved it and went back into Unity, I'd immediately get an error message at the bottom left. And if I click on it, it will open up my command console and it will tell me more about that error message. And you always want to open it up if you get an actual error message. If you see red and a stop sign with an exclamation point, that's a real error message and you want to take a look at it. If it's yellow and it's a warning, it may not be a problem. And some actual errors that are red are also not a problem. I get an error message in this version of Unity that we're using, 2019.211 F1. I get an error message all the time that my Unity editor is not responding or something like that, and it had to create a new one. That doesn't actually prevent my game from running. But other errors will, and when you look at them, it will tell you what line the error is on. And it will give you some kind of short explanation. In this case, it's saying it's expecting a semicolon and it didn't find one. Semicolon expected. And it's also saying right here that it's on line 1040. So, or line 10 is the main one. So in my power up pickup script. So I would want to go back to my script, find the power up pickup script, and go to line 10, and there it is. That's my error message. So it's giving me, it's line 10, and it's about 40% into the line. So here I can see that that's where the error is, and I'll put it back in and save it again, and that error message will go away. It should just disappear. Now, if it doesn't disappear, then I could go in and I could try to clear it, and if it doesn't clear, then I know there's still an error there, but it usually just disappears on its own once Unity updates. So always have terminators on your lines. That's a fundamental thing to understand about coding. And you should know certain basic procedures that are built into Unity. So the start and update procedure are built in. They're in every script that you create. And you run stuff inside of start that you want to put into memory at the beginning. And in some cases, you're going to declare variables at the top, and then you're going to set them in start. And then you can change them whenever you want if they're public inside of the editor. Now, oftentimes, if you are doing a public variable and you want it to be set in the editor before you even run your game, then you would want to put it up here and go ahead and put the value into it as I'm doing here. So I'm setting my rotation speed to 100, and that's going to be multiplied by time to make my power-up object spin. And it's public variable because I want to be able to change that. If it turns out it's spinning too fast or too slow, I can change that number inside of the editor by just, it'll be in a field, and I can just go change that. And we can go see that inside because I've already assigned this to these objects. So let's pick this one right here, this power up 1 object, and here you can see that it has the power up pickup script on it, and the rotation speed is set to 100, and I could type in there and change that to 80 or 120, whatever I want to make it that overrides what's in the script and will edit what I'm actually doing inside of the game. Now, I want you to notice that the name of this says rotation speed with a space between the words, and you have a capital R on rotation. That's not the way it is inside of the script. It's written rotation speed with no spaces, lowercase r, capital S, and that's called camel case. It's a standard scripting syntax that you use for variable names, and Unity knows that and will automatically put the space in and capitalize the first letter when it shows it in the inspector. So you want to use camel case for your variable names. If I didn't have public on this, it would not show up in the inspector, and it would just be set in here in the script. And that would be fine too. I could always come in here and change it. It just gives a little more flexibility if it shows up in the inspector. And you would just take out the public part, and it would remove that. I'll go ahead and save it. And inside of Unity, if I look at that again, when it updates, you'll see that disappears. Now there's no field for me to type it in. One fundamental thing that you should know when you're coding is your variable types. So this is using a float, but other variables you're going to see are going to be integers or strings, and these are all different types. Sometimes they're going to be animation types. Sometimes they're going to be sound source types and game object types. So that's something that you're going to have to look at the different script examples and try to understand what different types there are, because there are a lot of types. There are some main ones that you definitely want to know: integers, int. And when you start typing things in, it will help you to complete them by giving you the answer. Like if I started typing in an here, animation, I would eventually get where I could find the animation type. It's actually a class. So if I start to type int, it's going to come up in the list down here, and I could double click it and choose it. So I want float, and that's what I'm using for this particular one. I don't have anything in start for this script because I'm declaring and assigning the value to the variable in the same line. And like I said, you can do that separately. I could go down here and in start, I could say this part right here, put down in start, and take it out up here. So now public float rotation speed is being declared at the top, but it's being assigned in the start. It's more appropriate for things that you want to only be assigned when the game starts up, that you maybe don't care about showing up inside of the editor before you start the game. But if it's something like this, where, like I said, if I want to have that come up in the editor, then I would probably want to put it at the top here. Okay, so Update is another standard procedure that's in here. And you know something's a procedure if it's got void on it. That just means that there's no return statement. Sometimes procedures spit out some data after they run. And in this case, if it says void, there's nothing coming out of the procedure other than what the procedure does inside of its curly brackets. The parentheses after the name of the procedure are for arguments that go into the procedure. And that's kind of important, and we do use that sometimes. You can see that there's one down here on this onTriggerEnter procedure. There's actually something inside of the parentheses. And that's an argument. It means that we need to put some kind of data into the procedure. It's expecting you to put some kind of data into it. Start is not expecting anything, and update is not expecting anything, but onTriggerEnter is. So the main part of what happens inside of procedures inside the curly brackets, and it works the same as the curly brackets on the class. There's a start and end, and sometimes you will write start and end for those curly brackets, like I've done here on the onTriggerEnter procedure. I put trigger start and trigger end as comments to the right of those curly brackets. Remember that line comments like this comment everything out to the right of the 2 forward slashes. So you can always place them to the right of the actual code. Inside of my update, I'm animating my power-up object to spin in Y and also to sort of jitter and move in X and Z. I'm using a couple of transform commands for that. That's another built-in command to Unity. If you hover over these commands, it will tell you something about them. And the transform commands, any object that is a game object is going to have a transform. That's basically just the components at the top here. The very first component in your inspector is your transform component. That's your XYZ position, rotation, and scale. And so in this script, I am affecting the rotation and the position through a dot rotate and dot translate. Now this dot syntax that I'm using here is the syntax for C# to work with the classes. And this is working with the transform class, and it's getting access to the rotation of whatever object this script is on. So if I don't specify a game object at the beginning, then that means that it's whatever this script, whatever object, game object that this script is on, its transform is going to be affected by this. And so the script does go on the power-up object, the power-up prefab, which I'm using. And so this transform command requires the XYZ of the rotate and the translate to be set. And that means 3 numbers. And 3 numbers in 1 is called a vector 3. And so inside of the parentheses of the transform .rotate command, there is a new vector 3 being created. And that's also got its own parentheses that has 3 fields and separated by commas. And the first one is 0. The second one has a rotation speed times time.delta time. And the third one is 0. That means that the y-axis, because if it has to do with transform, it's 3 numbers is always going to be x, y, z. And the y field here is the only one that has something in it. The other ones are 0. So it tells you that when you hover over it, it'll give you some of that information. So I'm actually taking the rotation speed, which is a variable that's referencing the 100 value at the top, and it's multiplying it by time.delta time, which is the game loop. And so as numbers pump in there, it's multiplying that to create more rotation. The higher the number you're multiplying it by, faster the rotation will be. And then the second transform command has vector 3 in both the X and Z fields, and the Y field is actually 0. That's the Y field. And so that one is using a random range to create a random number between negative 0.1 and positive 1. And these two numbers are very small, but it will just create a little bit of a jiggle. Because this is in the update, it will update every game loop, and each time it will create a new position for the X and the Z from that random range command. And so that's going to make it move around a little bit, and you can see that if I go back in here and I walk up to one of these, you'll see that it's rotating and it's also jittering. And it's moving, so it could theoretically move to a place where I wouldn't be able to get to it. But it's moving very slowly, so likely I would be able to pick it up before it actually gets to some place that would be hard to access. So those are the movement controls that I have on this power-up object. And then to pick it up, I've got an on-trigger enter. So that means that I must have a collider on the actual object inside of Unity. So if I look, I've got a sphere collider on these objects, and I've got trigger turned on. So that's a fundamental thing to understand, is that we're always using colliders on objects. But sometimes if we want to pick something up, then we'll want to use a trigger collider because that will keep us from actually running into the object and stopping. For these objects, I can walk right through them, and when I do, they're going to disappear and I'll pick it up. I'll get some kind of representation on my screen that I've picked it up. And so that's what this on-trigger enter, which is another built-in procedure inside of Unity, and it's expecting an argument for what you collide with. So you don't actually have to put the argument in. All you have to do is have it on this object, on the script that's on this object, and it will automatically pick up the collision, and that collision will come in to this collider argument. It'll be put into a variable called collide, and it's of type collider. And you can then use that in the body of your procedure to check and see what you collided with. So my first line here is a conditional statement. If what I collided with, if its game object tag is equal means exactly equal to player, then we're going to do whatever inside of the curly brackets for this if statement. In this case, I want to take this object that I collided with. So I'm looking for the player. And to make this work, your FPS controller has to be tagged player, which is a built-in tag. You don't have to create it, you just have to set it. And it's always set up here at the top, right under the name. And if you set it to that, then if the FPS controller collides with this game object, it will be true that it collided with something tagged player. And if that's true, it's going to take that object that it collided with, which is the FPS controller, and it's going to look for it, look on that object, that game object. It's going to look for the scripts, and it's going to send a message to the scripts on that game object to run the cell pickup procedure. So it's looking for a procedure inside of the scripts that are assigned to the FPS controller, because that's what ran into, what collided with this power-up object. So as long as there is a cell pickup procedure somewhere on the scripts of that object, then this will be fine. Otherwise, it will give you a message that it can't find it, and you'll get an error message for sure. After it sends that send message to cell pickup, and this is a really good way of running a procedure on another object. But you have to have the name of that object. You have to have some kind of reference of that game object, and in this case, it's coming in through the collision. And you run send message and send this procedure cell pickup to it. You'll notice that this trigger doesn't really do anything but that. So it's not playing any sounds. It's not putting any GUI objects up on your screen, even though that's what happens when I pick up something. So if I go in and I hit play and I walk over to one of these objects and I pick it up, I hear a sound and I see a GUI reference come up on my screen, a GUI image on the upper left of my screen that says I just picked up something. So if that's happening, it can't be happening in this script. It's happening over in cell pickup. The only thing that's happening in this script is it's calling cell pickup and it's destroying the power-up object. So destroy game object with a lowercase g means destroy the object that this script is on. And in this case, it's going to be the power-up object. And it's doing it immediately. There's no delay or anything. So that's all that's in this script. So we want to go look at cell pickup, which is going to be on the FPS controller's inventory script. And so that's one of the other main scripts in here. I'll go ahead and open that up. And we've looked at inventory before, and we've looked at this cell pickup before. But let me go over that again. Here's cell pickup. So we know that because of that other script, somewhere in this inventory torch script, which is the version of inventory I'm using, there is going to be a cell pickup procedure, and it's a custom procedure that I created. It's not built into Unity. And so we're going to look at that procedure, but we're also going to look at this this inventory torch script in general. So there's other stuff in this inventory torch script as well, and I want to look at what that other stuff is. So if I play the game again, when I walk up to the door, it will not open. it gives me a message. There is a torch inside I need to get in, and it gives me a red light that is at the top, and those are the main things that I see that changed. It also put something up on my screen to sort of indicate to me maybe you ought to go try to pick up the weird looking power-up objects, because I've got one on my screen now. So that could indicate to me, okay, well, let's go and try picking one up. Okay, so now when I pick one up, I actually see a representation of that on my screen. Now, if I go try the door again, I still can't get in, and I get a sound that indicates that it's not going to open. And I get a change of the light color, and I'm also noticing now that there's also a change happening on the front. The symbols that were sort of dark and ugly looking are starting to get lighter. So that's kind of an indication of something changing as well. All right, so I'm going to go ahead and keep picking up objects. Actually, let's go ahead and make this a little easier for testing so I don't have to run around to the entire game to pick these up. So I'm just going to take this one that I have right here in my scene, and I'm going to Control-D, duplicate it, and make a new one, and we'll just move it over, and Control-D again, and let's just move that one this way, and we'll do Control-D one more time. So I have 4 of them sitting right there, easy to pick up. So let's run that one more time, and I'll go to the door. I get red, the error message. I go and pick up one, go to the door, and I get orange, and I get a different error message. I go pick up another one. All right, I get the same error message. And let's go ahead and pick up all 4. And I see that it turns green. And I see the texture map on the front got even brighter of the outpost, and it's indicating to me that maybe the door will open. So the door now opens. All right, so that is the main parts of this challenge, is to get 4 of these power-ups, and then the door will open. And before it opens, you're going to get different messages to tell you that you need to go get more. It's not going to open, something like that. So let's take a look at the scripts that are doing this. If we open these up, we have several main scripts here that we have to look at. Inventory and trigger zone are the 2 main ones that we definitely want to look at. The inventory torch I was just looking at a second ago. You'll notice I've added a new line, Unity Engine UI. This is an important line for GUI objects. Whenever you have GUI objects, you're going to have that Unity Engine UI in there. Otherwise, it's not going to find the UI commands that you use in your script. And this script goes on the player controller, the FPS controller. And the main thing about it is you're going to have a charge global variable that is going to basically be your score for picking up those power-up objects. And it's an integer variable, int, because we need to get 4 of them. You can have 5 or 6 of them, but it's going to be integers, and it's going to start at 0. So public static int, this is an important thing to know, the difference between a local variable to this script and a global variable that can be referenced by other scripts is the public static. If it says public static, it is a global variable, and other scripts can reference it. And if we go, for instance, to the trigger zone script, which we're going to look at, it's actually looking at that charge variable using the name of the script, inventory torch dot charge. So it's using the dot syntax again, and it's putting the name of the variable after the name of the script. And that's how a global variable is referenced. So we're creating that global variable here. I've got a lot of my global variables in this script because they're easy to find that way. You don't have to do that, but you have to be aware that you don't want too many of global variables because they stay in memory throughout the whole game. And you want to be able to keep track of them because if you restart your game, you need to reset all those global variables because they are persistent in memory. So if you're restarting, you might have to set those back to their original default settings. So after this, I have a public audio clip collect sound. So that's the sound we're hearing when we're picking up those power-up objects. And we need to bring it into this script in some way because we're playing it on this script. We're not playing it up on the power-up script. We're playing it on the inventory script, which is on the player. And it's of type audio clip. And the name of it is collect sound. Public, meaning that it's going to show up in my inspector and I'll be able to drag my sound right onto it. We have other variables here for a public texture 2D meter charge and a public renderer meter. These are brought over from the previous script, inventory script that we were using. That was from the tutorial that we used in class. And I'm using them for different purposes in my game, but I left them named the same. So, so I have a meter charge, even though I'm not using a meter anymore. This is a regular texture map that's going to be on a model of some kind. So it was originally on a generator model, a generator meter model, which was just showing you how many charges you had as a visual representation. What I'm using it is for a wall texture. And so I'm going to put or wall. I'm changing the texture on the front of my outpost, my front wall. And that's the object that I'm plugging into it. Instead of a meter, I'm plugging in the wall. And the texture maps are regular 2D textures. There's 5 of them. And they're being plugged into a meter charge variable that is a special variable called an array. And whenever you have hard brackets like this, that means you're dealing with an array. And I've got 2 arrays here. That is a variable that takes multiple objects into it, in this case texture maps. And we're going to have 5 of them. And you could have more. You can have as many as you want. But we're not setting the size of the array here. It's just going to be an empty array that we'll have to plug in the inspector. It's public so it will show up in the inspector. The second one here is a raw image, and that is actually a GUI object. That's the image that comes up on the screen when you first walk up to the door, and changes whenever you pick up a power-up object. And that's actually a 2D GUI object that is being placed on your screen. That's why we needed the Unity Engine UI line at the very top. Otherwise, you'll get red when you try to put that raw image line in there. So those are the main things in this particular part of the game inside of Inventory Torch. There's other things in here because this is your FPS controller, so pretty much all the things that I'm doing have something to do with the FPS controller. There's going to be things for lighting fires and torches and disabling portals and stuff that I have in here that is for other parts of the level. But I'm going to skip those for now and go down to the start procedure. So start procedure is where I'm actually setting the charge to 0. So this is where instead of declaring, we're actually doing assignment of the charge. And so every time we start the game, it's going to start at 0. And it's going to go up from there. And that charge number, as it goes up, is actually going to drive the texture maps that come up on the front of my outpost and also on my GUI, my heads-up display. So there is a charge HUD GUI object that is hidden, so it doesn't show up in the GUI in the heads-up display from the beginning, and that's set in .enabled flag on that is set to false. So again, that's dot syntax, and you often use this .enabled to hide and show either GUI objects or the renderable objects on 3D objects. So if you want to hide something, it's this .enabled property, and I'm setting it to false. That hides it. And then later on, we're going to reveal that. So if we go down to cell pickup, which is the actual procedure that we were calling from the power-up script. So inside of the on trigger enter of the power-up script, we call cell pickup on inventory, and it's called on inventory because the player is what collides with the power-up object. And the first thing it does is run HUD on procedure. So both the HUD on procedure and the cell pickup procedure are custom procedures that I have made in order to do some particular thing. In this case, the picking up of the power-up object. And the HUD on, all it does is show the charge HUD GUI. So it takes the charge HUD GUI and enables the visibility of it to true. And it does that if it's hidden. So it checks first this if statement. It says if the charge HUD GUI is not enabled. So one of the fundamental things in coding in C# you need to learn is the not symbol. It's this exclamation point. So if you put an exclamation point, if you have a if conditional statement, it always evaluates what's in the parentheses to being true. However, if you put a not symbol in there, it's going to evaluate it as being false. So if it is false, if it is true that it is false, it's a little bit convoluted, but that's the logic of it. What's this? What this is saying? If it is true that not charge HUD GUI is enabled or false. Then run what's inside of the curly brackets, which is saying make it true, and reveal it. So if it's hidden, reveal it. And up here under the cell pickup, after it runs that line and shows the GUI, it's going to then bring up the charge HUD GUI.texture according to the charge setting. So if the charge setting is 0, it's going to bring out the first thing in the array. If the charge setting is 1, it's going to bring out the second thing in the array. Before it does that, it's going to play a sound. That's why we brought in some audio at the top. We brought in an audio clip, collect sound. And then down here, we're playing that. In order to play it, you have to have an audio source on your object. So if this is on our FPS controller, it will have an audio source because it has one on it by default. If you don't have an audio source, it will give you an error message. And the line we're using to play this is audio source.playClipAtPoint. There are several ways I'm using in these scripts to play audio, and they're all valid ways of playing audio. They do them a little differently. This one's playing a clip at a particular point in 3D space. And it's playing it where it's playing collect sound at the position of our FPS controller. So transform.position is referencing the position of the object that whatever this script is on. And in this case, that's the FPS controller. Charge ++ is incrementing the charge. So whenever you run cell pickup, it's incrementing the charge. The first time it runs, it's going to make a charge of 1. And it's going to pull out images for both the texture map on the front of my outpost and on the GUI. It's going to pull out 2 texture maps. So let's go in and take a look at that on the inventory torch script to make sure you understand where that's happening. If we look at that, these are the things that are in the inventory torch script. When you put it on the FPS controller, they're going to show up in the components. So you're going to go to Add Component, Scripts, and you're going to choose the inventory torch script. And when you do that, it's going to come in and these things will be collapsed. So you're going to have to open up the drop-down arrows for where the arrays are for the meter charge and the HUD charge. And they won't have anything in them. They'll have 0 in them, so you have to put 5 in them to get 5 spaces. And you can see that they're numbered spaces from 0 to 4. So when the charge number is 0, it's going to pull out whatever is the very first image that you plug in for both the GUI HUD and also for the texture maps that are for my wall. And those are just objects that I have inside of my textures folder. The ones for the wall look like this, and I just drag them into the spaces here in the order that I wanted them to come up. They go from a very dark, ugly texture to a very sort of light white texture on the front of my outpost. So they change every time I pick up a power-up object. And then the other ones are for the HUD, and those are GUI textures, and here they are, and they're plugged in each one at a time in the order that I want them to come up, and they get bigger and they also change colors. So you can do however you want based on your aesthetics and your narrative that you're using in your game, and these type of objects that you're collecting. It doesn't matter. It could be food. It could be batteries for a flashlight. It could be anything. And as you pick that up, you want to give some feedback for it. And in this case, I'm doing it mainly with the HUD objects, but also the front of the wall is just some visual interest. It's really not telling you very much. So these GUI objects have to be set to Editor GUI and Legacy when you bring them in. I made them inside of Photoshop. I just did a screenshot of the object inside of Maya, or actually not even in Maya, inside of Unity. After I imported it, each one of these objects, power-up objects, is a, you can see that it's blue, which means it's a prefab. So that means there's a prefab object that these were created. I created it and then dragged it into my prefabs folder. And so I went into the prefab object and opened it, and I just did a screen capture, turning off all my gizmos so that, and unselecting it, and doing a screen capture of that and bringing it into Photoshop to make my GUI object. And I had to cut out the blue area around it so that I would get some transparency. But when you bring those back in as texture maps inside of Unity, they won't have transparency if you don't set them to Editor GUI and Legacy GUI. So they need to be PNG files, and they have to have an alpha channel. And then you're using the alpha for the transparency. You have to make sure that's checked, and Editor GUI and Legacy GUI is set. And then they'll have the transparency, so when they come up on your 2D HUD, that they'll have the transparency around them. So make sure you do that. Okay, so going back to my FPS controller, I plugged in all of my different objects that I needed. I needed to plug in the front wall for the actual object that's being changed for the texture map. You got to just drag that in on top of the FPS controller. For that renderer to change that texture where it says meter, I put in the mesh renderer for that. And then I put in I had to create a GUI object and plug it into where it says charge HUD GUI. So your GUI objects, as soon as you start creating them, are going to come up under a canvas object inside of your hierarchy. And we did a crosshairs before, and that came up as a canvas object. And now we're making other objects, and in this case, it's the charge HUD GUI object. And for that, you're going to want to plug in some kind of texture map. And you're going to want to reset it and make sure you set native size. Click that Set Native Size button. It's going to come up in the middle of your screen. And to move it where you want it, mine's up in the upper left. You just have to adjust the numbers for position in X and Y. So you can see mine's using -700, which pushes it over to the left, and 350 in Y pushes it up into the upper left corner. After you do that, you can turn off the raw image because you're actually enabling and disabling that in the script. It will do that for you in the script. It'll turn it off if you forget to turn it off. But I usually just turn it off anyway because I don't need to see it in my game view. So that's what the dot enabled in the script does. When we run HUD on and it runs charge HUD GUI dot enabled equals true, it's turning that on. And in start, when I set dot enable to false, it's making sure that's not visible at the beginning of the game. So pretty much that's everything that the torch, or not torch pickup, the cell pickup does. The main thing being incrementing this charge. And that's being used by the trigger zone hinge script. So the trigger zone script, or the trigger zone hinge, is the one I'm using. It's got a couple of new things that are different than the original, but a lot of it is the same as the original. You can see that it's using some UI elements, so it's got the line at the top for the UI. And this one is going to go on the outpost object, so the main structure that is parented over the door. So if I go back in and look at that, here's my outpost new. The hinge anim is where my animation is, and also my control, my door animator script is there as well. But the actual animation that I brought in from Maya goes to the very top node, because that's just what it does when you import it. And that has the animator control for opening the door. So the animator component, I'm using an animator component. You could use an animation component. I showed both ways in the last video, but I'm still using the animator one, which was at the end of the last video. My outpost object has the animator controller on it, and it also has a box collider on it. So the box collider is what's actually going to do the collision with the player to find out if I want to open the door. And I used this in the last video. I turned my gizmos off, so let me just turn that back on so we can see it. And you can see it sticks out. And look at that other previous video in order to see how to set that up. So in the trigger zone script, which has several inputs into it now. It's got a lock sound input, a door light input. So I have a door, a point light above the door, and that's being plugged in here. It's got a text hints, which is some GUI text that comes up, and it's got a door open and a door shut sound coming into it as well. So all of that is inside of the script. It's the first public variables that we have at the beginning of the script. And here's several types that some of which we've seen before, like audio clip type we've used in the power up script or in the inventory torch script. And the new ones here are a variable of type light and a variable of type text. And we are using Unity UI because of the text. So we also have an audio source, audio player source being declared at the top, and that is to have a variable as a container for an audio source on this object that we're going to find the name of by using a get component command in the start procedure down here. We're also setting the light color. The light is being plugged in at the top, but the light color is being set here in the start to be blue, which is a keyword for a particular value, RGBA value, which is 0011. So RGB is red, green, blue. 001 is a full blue color. And 1 in the fourth setting for A is alpha, meaning that it's visible. So we've got a door color being set for the light, and we've got the component of the audio source being put in so that we can play a sound. And then the rest of this script is going to be controlling whether you can get through the door or not, and changing the color of the light, and also giving hints by putting text on the screen for the player. So if we go to, I'm going to skip update for right now because update is running in a loop and it's always checking to see if we actually get all 4 charges. But I'm going to skip that for right now and go down to the very bottom where the trigger is. So here's the procedure for the trigger that is on the front of the outpost. And it's checking to see if we're colliding with the player in the very first line. And then after that, it's checking to see how many charges you have by referencing the global variable that is inside of the inventory torch script. So the first thing it checks is, do you have 4 or greater charges? So the reason you want to use greater than or equals to 4, or whatever you use in 5, 6, it doesn't matter, but you want to use greater than or equals to, because that's going to allow for an error to occur when you're picking up your power cells or power objects. Sometimes, because of the game loop, you might collide with a collider and maybe you disengage from it and you collide again really fast, in which case it might actually register a collision twice with that one collider, and you might get 2 pickups instead of 1. And if that were to happen, then you would actually maybe have 5 charges when you pick up 4 power objects. And that would, if this said equals equals, which means exactly equals to 4, then it wouldn't be true, and you wouldn't be able to get through the door if you had 5. So you would, by setting it to greater than or equals to 4, then even if you have 5, you're going to be able to get through the door. And then if that's true, if that evaluates as true, then it's going to run a send message to the hinge anim object, which is actually where my door animator script is, and it's going to send a message to that script to run the door check procedure, which is the procedure we're using to open the door. And then after that, it's going to destroy the charge HUD GUI after 2 seconds delay. So the destroy command is looking for the object you want to destroy. In this case, it's running a game object find on charge HUD. That's the actual name of the HUD GUI that I'm using for the power-up objects. And it's doing a comma, and if you put a floating number after that, it's an optional argument into the destroy command to run a delay. So if you put 2, it's going to wait for 2 seconds before it destroys it. And that just allows you to see for 2 seconds, you see that you got the green 4th HUD image on your screen, and then it disappears because you don't need it anymore. And then we're going to go to the next one, else if. It's going to drop down after it runs if. And if that's true, it's not going to continue down. But if it's false, if the if line ends up being false, then it's going to go to else if, and it's going to check to see if inventory torch.charge is greater than 0 and less than 4. So this line is checking to see if you've got 1, 2, 3 charges. And if you do, it's going to play a locked sound. So it's doing a play one shot. That's different. It's using the audio source that we got the component of in the start, and it's playing one shot, which means playing it once. It's another way of playing sound. It's setting my color of my light to orange, and this is a custom color, so I had to use a new color command, which actually sets the values of the RGB for that color. You can find those inside of Photoshop, or you can just try to figure them out. One, in this case, the first field is R, so that's going to be a full red, and the second field is G. Half of a G is going to kind of make a reddish orange color. And the third field, of course, is blue. So there's no blue. So that's my color orange that I'm setting there, and then I'm setting the light to that color in the next line. And then it's also giving me a hint, a text hint, telling me the symbol above the door matches the floaty things. Let's get more. And you notice this \n, that means new line character. So that puts that the floaty things, let's get more, on a second line. That's how you put it on multiple lines. Otherwise, it'll be too big and it might go off the screen. That's for a text object. And I'm sending it to an object called show hint, or actually it's the text hints object I'm bringing in at the top up here. So a text object I'm bringing in, calling it, putting in a variable called text hints, and then I'm sending a message to that object to find the show hint procedure and put this argument, this string argument, into it. Both of these are actually strings. The first one is the name of the procedure. The second one is the argument, which is actually going to be looking for that. And if I go look at that text hints script that has that in it, you will see that there is inside of that a show hint procedure that has an argument, a string type argument coming in for the message. And it's just going to take that and set that message into the text .text component of the text object, and then it's going to, if it's not enabled, it's going to enable it to reveal it. So each one of those lines is bringing up the text, and then there's a timer in the update that is going to hide the text again. So as soon as it's enabled, if it becomes enabled, it's going to run a timer that we set at the top to start at 0. And we set the limit of that timer to be 5 seconds. And you can make that limit anything you want. You can make it a public float variable and change the length of it whenever you use it if you want to. I'm using 5 seconds. You might want a little longer. Let's put 6 seconds in there. And that's going to now run for 6 seconds. And the way it works in the update, this is an important thing to know. You can use this as an example of a timer. I'm using it actually in several different places inside of my scripts. You're using the time.delta time to tick off a timer. And it's only doing it if something is true. So in this case, if the hint becomes enabled, which means it's revealed, then it's going to start the timer. It's going to plus equals, which means add the time.delta time, which is always ticking off, into the timer. And once that timer becomes greater than or equals to the time limit, which we set to 5 or 6 seconds, then it's going to make the hint enabled to false, which will hide it. And it resets the timer for the next time you use it. So that's something that you can use in a lot of different places to run a timer, as long as you understand how that works. So the trigger zone script is using that in the text hints when it sends a message. And in order for that to work, you actually have to have a text object to plug into this. If I go back into the game, you'll see that I am plugging in a text hints object here into the trigger zone script, and you have to create that over in your canvas objects. It's a text object, and you just create it by going to UI text. And it's just going to come up with some a text object that will be in the middle of the screen, and if I type something in here, usually it will come in with some kind of text in it, and you'll see that. You can see it's on the bottom of my screen because I've moved it to -425 in Y to move it down to the bottom. But it's centered in my screen. Now, when you first make it, it might be so small you can't even see it, and it will probably be a dark color. So you gotta, if you want to see it like I can see mine, because I made it a white color, I chose a white color, and I made the text font size to 70. So you can choose a font, make sure it's centered in your paragraph stuff, and then always put it to overflow for both horizontal and vertical. That way it won't get cut off. So set all of those settings, and then you can put your text hints script on it and set the limit length to whatever you want. I think I put it at 6 in the script, but I must have overrode that before to 4. I'm going to put it back up to 6 here. And then you can select the text that's in the text field. That's what you're actually inputting with the script, and just backspace out of it so there's nothing in there. And that will actually make it so that it's not visible. And it will become visible when it puts the text into it from the script. So when the trigger zone hinge script sends the message with some text in it, that's when it will actually fill that field. So after it does the else if, looking for a number of power-ups that are between 1 and 3, then it's going to, if that's false, if it's not between 1 and 3, then it's got to be 0. You haven't picked any up. So it's going to drop down from else if to else. And in that case, it's just the default. You haven't picked up any yet, but you've walked up to the door because you've hit the trigger, and therefore it's going to turn on your HUD. It'll show you the default image that you have plugged in to your HUD object. And then it'll play a locked sound through your audio source. It'll make the light color red, and it'll give you a message to your text hints that says, there's a torch inside, I need to get in, \n for new line character. What are those floaty things? And then you can walk over and check the power-ups, pick up one of the power-ups and try it again. So that's kind of how that script is working. There are nested conditional statements within an if statement here. And when you do that, you have a lot of curly brackets that you have to be careful that you make sure they're all closed and in the right places. So that's why I have all of these comments in here to make sure nobody gets confused about where the curly brackets are ending. Now there are a couple of the other things in this script. There is an update, which is checking to see if you have, so this is always looking because it's in update and it's running continuously with the game loop. That's what update does. So it's always checking to see if you get greater than or equal to 4 charges, and if it does, it's going to find the charge HUD and see if it exists, and if it does, it's going to change the color of the light to green in this line, and it's going to give you a hint that says the light is turned green. Let's go check it. So that will stay up there continuously because this charge HUD continuously exists and update is running continuously. So that message actually won't disappear. It'll just stay up there. And the reason for that is if you're like on the other side of the world and you pick up something, you're not going to be able to see whether the light actually turned green on the object. It's just telling you that maybe you should go back and check that. You might not want that. I mean, it might be too easy if you do that. And you could change some of the things in here to make it so that it didn't continuously run as true. But because it's in update, that's going to continuously run. Okay, so the other thing that I have in here is I have a door open sound and a door close sound. And the reason these are in here, this is just for playing one sound one time. And it's for the door. And I needed to have a couple of procedures that would do only that. And the reason I needed that was because sometimes when you run a sound from a script, it won't always sync up with the animation on the object. And so I was finding that happening when I was trying to run the sound through the animator script. So I actually took the sound out. Originally, we had the sound playing from the door manager script, and that became the door animator script. So if I go to my scripts again, I'm using, instead of the door manager, I'm using a door animator. And it's basically very similar. It's the same as the door manager, except that it doesn't have some of the things that the door manager script had in it. The sounds are not being played from this anymore. Only the animation is being played. And the reason I did that is because the sounds were not syncing up with the animation. They were a little bit off. And that happens sometimes when you have an animation that's triggered in your scene through a script. The animation is triggered through a script, and the sound is triggered through the same script, so that they're actually happening slightly offset from each other, and they can actually separate and not play at the same time. So what I did instead was I trigger the sound from the animation, and in that case it will always play at the right time. And to do that, you actually have to go into the animation itself. I have my hinge anim, and it's got that animation script on it, and it's got a audio source because it actually doesn't need the audio source. It's not playing any sound. Actually, I don't think from the script. Let me just check that. Yeah, there's no sound being played from the script. So originally it did, but I don't need that audio source anymore, but it's still there. It's not hurting anything to be there. But the actual animation is on my top node right here, and it's on the animator. It's got an animator controller, and the animation is plugged into it. So if I go look at the animation itself, if I go find the animation that I brought in, now if I bring it in with a, if I'm not creating it in Unity, that's going to be actually where my models are. So that's going to be actually on my door. And I'd want to find my models, go find my door animation, open it up, and that's where my door open, my door shut, and all of that is going to be. And so if I go select that import object and look at the animation that's coming in, there is, so this is my import settings that I set, and I'm using generic. You might be using legacy, and that's fine. But I'm using generic, and I separated out my different animations on my door from the overall animation that came in, which was take one. And we talked about this, and I showed this in the video where I brought in the door from Maya. So if I click on my different animations, like my door open and my door shut animation, there is a little events setting down here. And you can actually put an event into this by hitting the plus sign here. And you can see I've got a door open sound event that happens on my door open animation. And you just click on that, add event, and it's going to allow you, if there is a script on here, you can add a new event that will look for a script, and you can name that. So let me go ahead, and I'm going to revert that and just click on this one so you can see the one that's already there. So the function that I'm calling is door open sound. And if you go look at the script that I'm using here for the trigger zone hinge, I've got door open sound function or procedure, and it's playing that open sound. And then I've got a door shut sound procedure here. So if I go back to Unity and I select the other one, the door shut one here, and click on the event that I've added here, then you can see it's using the door shut sound. You have to create it, add it, and then put the exact name that you're using for that procedure on the script that is on this object. Okay, so this object, the object that has this animation on it, has a script on it, has the trigger zone hinge script on it that has this procedure in it, and it will find it. And it will run that procedure at this point in the door open animation. So you just play your animation and figure out where that sound should start playing at, and it will run that. And it will always run, and it will never separate like it does if you try to play it from the script sometimes. So in that case, I don't do that unless I actually find a problem where it's separating and it's not playing at the right time. But if it is, that's a way of fixing it to actually connect it as an event on the animation itself. And that's all there is to the Trigger Zone hinge script. So the other script is Door Animator. That's actually on the hinge object that I animated inside of Maya to do the animation for the door. And it's the same as the Door Manager script that I've talked about before. However, I have removed the sound parts. And since I removed the sound parts, I edited the procedure that is actually opening the door to not have that argument. So I removed the argument. There's 3 arguments in this procedure when there used to be 4, and one of them was for the sound. So each time I use this in door check to open the door, now I have 3 arguments. One of them to say that the door is opening, the other one to specify the state of the door, in this case because I'm using the animator controller and setting that to a state of 1. So this one is the edit for using the generic animation setting and the animator controller as opposed to legacy and the animation component. If I was using the animation one, I'd be specifying the name of the animation. Okay, but see the other video to see how to do that. And that's all of the scripts with the text hint script. I believe that's all of the scripts that I'm using for that section of the project of the door challenge. And that's all I'm going to talk about for this video. In the next video, I will go into the mini game and talk about how that works, the hatchet throwing mini game.